Adopting a process model. The process should be agile and adaptable to problems. The process adopted for one project might be significantly different than a process adopted from another project. Among the differences are the overall flow of activities, actions, and tasks, and the interdependencies among them. The degree to which actions and tasks are defined within each framework activities. The degree to which work products are identified or required. The manner which quality assurance activities are applied. The manner in which the project tracking and the control activities are applied. The overall degree of detail and rigor with which the process is described. The degree to which the customer and other stakeholders are involved with the project. The level of autonomy given to the software team. The degree to which the team organization and roles are prescribed. Prescriptive and agile process models. The prescriptive process models stress detailed definition, identification, and application of process activities and tasks. Intent is to improve system quality, make projects more manageable, make delivery dates and costs more predictable, and guide teams of software engineering as they perform the work required to build a system. Unfortunately, there have been times when these objectives are not achieved. If prescriptive models are applied dogmatically and without adoption, they can increase the level of bureaucracy. Agile process model. The agile process model emphasizes project agility and follow a set of principles that lead to a more informal approach to software process. It emphasizes maneuverability and adaptability. It is particularly useful when web applications are engineered. The essence of practice. How does the practice of software engineering fit in the process activities mentioned above? Namely, communication, planning, modeling, construction, and deployment. George Poley outlines the essence of problem solving, such as: first point, understand the problem, that is communication and analysis. Second point, plan a solution, that is modeling and software design. Third point, carry out the plan, that is code generation. Fourth point, examine the result for accuracy, that is testing and quality assurance. Understand the problem. There are four questions. Who has the stake in the solution to the problem? That is, who are the stakeholders? Second question, what are the unknowns? What data, functions, and features are required to properly solve the problem? Third question, can the problem be compartmentalized? Is it possible to represent smaller problems that may be easier to understand? Fourth question, can the problem be represented graphically? Can any analysis model be created? If you are able to answer these four questions, it implies that you are able to understand the problem. Plan the solution. Have you seen similar problems before? Are there patterns that are recognizable in a potential solution? Is there existing software that implements the data, functions, and features that are required? Has a similar problem been solved? If so, are elements of the solution reusable? Can subproblems be defined? If so, are solutions readily apparent for the subproblems? Can you represent a solution in a manner that leads to effective implementation? Can a design model be created? Carry out the plan. Does the solutions conform to the plan? Is source code traceable to the design model? Is each component part of the solution probably correct? Has the design and code been reviewed? Or better, have correctness proofs been applied to the algorithm? Examine the result. Is it possible to test each component part of the solution? Has a reasonable testing strategy been implemented? Does the solution produce results that conform to the data, functions, and features that are required? Has the software been validated against all stakeholder requirements? Hooker's general principles for software engineering practice. Important underlying law. Help you establish mindset for solid software engineering practice. There are 7 principles we need to remember. The first one, the reason it all exists. Provide values to users. Second point, KISS. Keep it simple, stupid. As simple as possible. Third point, maintain the vision. Otherwise, incompatible design. Fourth point, what you produce, other will consume. The code with concern for those that must maintain and extend the system. Fifth point, be open to future. Never design yourself into a corner as specification and hardware changes. Sixth point, plan ahead for reuse. Seventh point, think. Place clear, complete thought before action produces better results.